Hi everybody, this is Form 1 Chapter 1 Rational Number Revision Part 2. In the previous video, I already discussed question number 1 until question number 5, right? Okay, in this video, let me continue discussing question number 6 until question number 8. Okay, let's look at question number 6. Which of the following are rational number? So any number, if they can be written in this form, which q is not equal to 0, if it can be written in this form, fraction form, then it is rational number. Okay, remember. So is 0 a rational number? Yes, because you can change it to 0 over 1, right? How about 4? Yes, 4 over 1. Negative 3? Yes. Negative 3 over 1. This one. This is a mixed number. If you want to change this to improper fraction, this is equal to 3 times 2, you will get 6. 6 plus 1, you get 7. 7 over 2. Okay, so these all are rational number because they all can be written in this fraction form. Okay, now you look at this decimal. This is recurring decimal. Means that part of the decimal keep on repeating. When you see 3.422, you see the question write so many times of 2 for you. This means that the question want to let you know the 2 keep on repeating, no ending. You see a 3 dot over here, right? So it means that keep on repeating. So this is recurring decimal. So yes, it can be written in fraction form. So if you see a decimal keep on repeating, if you see a decimal that does not have an endpoint, it means that it go infinitely. We also can call it as non-terminating decimal. Means that no endpoint. The decimal does not have an endpoint. Non-terminating decimal. Okay? This one we also can call it as recurring decimal because the 2 keep on repeating. So if I ask you what's the next digit, you know which is 2, right? So this is a rational number. You can change it to a fraction form. How to change it to a fraction form? You are going to learn it in the futures. So currently, if you want, you can actually use a calculator to help you. So you can try this way. 3.4222. Okay, if you just key in this way, you press equal, you change to fraction, cannot. So you have to press many times of 2. 3.4222, many times of 2. Okay, then press equal. Your calculator will automatically help you to change this recurring decimal to fractions. 154 over 45. 154 over 45. Okay, it can be written in a fraction form. Therefore, this is a rational number. So let's check again. Now, let me key in 154 over 45. Then press equal. Change to fraction. Change to decimal. Yes, 3.42222. It just go infinitely. The 2 keep on repeating. This is called recurring decimal. Okay, how about this? This decimal has an endpoint. This is the last digit, no more digit at the back, right? So this one we can call it terminating decimal. Means that this decimal has an endpoint. Terminating decimal. Until here, stop. No more digit at the back. So terminating decimal, definitely it is a rational number. Because how to write this in a fraction form? I think you should be no problem. 1342 over 123 over 1000, right? So you can check. Use a calculator if you are not sure. 1342 over 1000. Change to decimal? Yes, 1.342. So how about if I give you a little bit longer decimal? 0.654789. Try to guess. Not try to guess. Try to think. Is this a rational number. This is a terminating decimal, right? So definitely it can be written in a fraction form. How? You can just write this 654,789 over, okay, 1, 2, 3, 4, 5, 6. We need 6 0. 1, 2, 3, 4, 5, 6. You can check by using your calculator. 654,789. Let me check again. 654,789 over 1, 0, 0, 0, 0, 0, 0. Press equal. 654,789. Okay, yes, correct. So this is a rational number because it can be written in a fraction form. Okay? Yes, this is a rational number. How about this? You see a 2 dot here. This 2 dot is to tell you that this 1, 2, this 2 number keep on repeating. That means 0.3, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, does not have an endpoint. It just go infinitely. Okay, so remember this is a recurring decimal because part of the decimal keep on repeating non-stop, no endpoint. Okay, is this a rational number? Yes, this is a rational number. So again, if you want to use your calculator to help you to change it to a fraction, you just press 0.312. You press like this. You have to press many times. Okay, now let's use our calculator to help us change it to fraction. 0.3121212. Okay. Keep on repeating 1, 2, 1, 2, 1, 2, 1, 2. Okay. Try to press equal 103 over 330. Let's check. 103 over 330. Okay. So is this equal to 0.3? 1, 2, 1, 2, 1, 2, 1, 2. Let's see. 103 over 330. Press equal, change to decimal. Yes, 0.12121212 keep on repeating. It goes infinitely, no endpoint. This is called non-terminating decimal, no endpoint. And because the 1212 keep on repeating, we also can call it as recurring decimal. So for a recurring decimal, yes, we can write it in a fraction form. So yes, this is a rational number. Okay, how about this one? 0.123645893 3 dot here. Okay, so don't get confused. If the question write this way, it means that this is a non-terminating decimal. It's go infinitely, and if I ask you to predict what is the next digit, we don't know. If the question want to tell you that the 9 keep on repeating, it will write many times of 9 to show you that the 9 keep on repeating. If you see this case, this situation, it means that this is not a recurring decimal. So this cannot be written in fraction form. Not a rational number. Okay, this is pi. Okay, pi, sometimes you will see the books will ask you to use 3.142 or 22 over 7. But actually, pi is not exactly equal to 3.142 or 22 over 7. These two values just approximately equal. The pi is just approximately equal to this, a value that close to pi, but it's actually not exactly equal to this two. So if the question asks you, you can just search online pi. It's just continuous infinitely, and you don't see any pattern keep on repeating. So this is a non-terminating decimal because it's go infinitely, and it's not a recurring decimal. You don't see any part that keep on repeating. So in this situation, pi is not a rational number. Okay, E, the same thing. This is Euler number. This is not a rational number either. So you can just key in on, go to Google and search the ordinal number. You see it go infinitely, no endpoint, non-terminating decimal, and you don't see any part keep on repeating. Okay, so hopefully after this question you know how to differentiate what is a rational number, what's not a rational number. Okay, now let's look at question number 7. A sport shirt needs 2.64 meters of cloth. Cindy buy a few meters of cloth to make some sport shirt. After cutting the remaining length of the cloth is 0.95 meter. Calculate the length of the cloth that Cindy bought if she asked the tailors to make 5 pairs of the same sport shirt. So we have 5 pairs. So sometimes if you don't know how to solve it, you can just simply draw a diagram. A 5 pair of shirts. You don't have to draw a shirt out. Just simply draw a line. 5. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Just assume that everyone is the same length. Okay, so one sport shirt, we need 2.64. This is 2.64. Same thing here, 2.64 meter. 5 sport shirt. Everyone needs 2.64 meter. Okay. So after making this 5 same sport shirt, the remaining part is over here, which is 0.95 meter. So the question is asking us the length of the cloth that Cindy bought. It means the total length of this, right? So the length of the cloth will be 5 times 2.64. Okay, then you get the total length for here. And don't forget to add the remaining part, which is 0.95. Okay, so I would suggest you don't just key in, don't just press the calculator and give the final answer. Show your step clearly. 5 times 2.64, which is equal to this 66 over 5. If you want to change to decimal, 13.2. 13.2 plus 0.95. Okay, so the 13.2, your calculator can remember it. What you just need to do, just press plus, and you see answer. This answer means 13.2. You don't have to re-key in again the 13.2. 0.95. Okay, 14.15. Okay, let me check the answer correct or not. 14.15. Okay, final answer. Remember to write the unit. Let me double check again. 5 times 2.64 plus the remaining part, which is 0.95. 14.15 meter. Okay, correct. Let's try the last question. Container P has 350 grams of flour. Okay, yes, 350 grams of flour, and 2/5 of the flour in container Q is poured into container P. Then 3/9 of flour in container P is poured into the empty container R. Now, container R has 306 grams of flour. Calculate in gram the mass of the original flour in container Q. So this question looks so confusing, right? So sometimes if you don't understand the question, you can try to draw a diagram to help you. So container P has 350 grams of flour. Let me draw container P first. 350 grams. 2/5 of flour in container Q is poured into container P. So I have another container Q. I don't know the mass of the flour inside the container Q. The question is asking us to find the original flour, the mass of the original flour in the container Q. So 2/5 of this is poured into here. So that means now the container P contains more than 350 grams of flour. Okay. Okay. So after pouring 2 over 5 from container Q to P, it will become more. Okay. Then 3 over 9 of flour in container P is poured into an empty container R. So the R from 0 gram to 306 gram. Okay, so we want to calculate in gram the mass of the original flour in container Q. So after drawing this diagram, I think it will be easier for you to plan how to solve it. So this is 3 over 9. Okay, so let me calculate from here, go backward like this. This is beginning is a 0 gram. So we know that 3 over 9 of this 350 plus here is actually equal to 9 over 3, right? Total 9 part. 306 represented by 3 part. Okay? Now, so what you need to do is just take 306 divided by 3. We want to know 1 part. Then total is 9 part. You times 9. Okay, just press your calculator. 306 divided by 3 times 9. 918. 918 gram. Okay, so 918 gram. So originally the P contains just 350 gram. So why become 918 gram? Because part of this is from here, right? So you just take 918 minus 350. 918 minus 350. You get 568 gram. Okay, let me draw over here. 568 gram. So this 568 gram is from this container Q. 568 gram. Okay, total 5 part. The 568 gram represented by 2 part, right? So if you want to know the original mass of flour in container Q, you can do it this way. Okay, so 568 represented by 2 part. 568. I want to find 1 part divided by 2. So total 5 part times 5. So you will get the original mass. 568 divided by 2 times 5. 1420 gram. Okay, so this is the way how we solve this question. So sometimes after reading the question you feel very confusing. You can actually draw a diagram to help you to understand the situation, and it's actually easier to let us plan it how to solve it when we see a diagram. Okay, that's all for this video. See you next time. Thanks for watching. Bye bye. Okay, for this just now I forgot to tell you that for the order number and pi, you can actually use your calculator to help you to get the value. So pi, you can just press, you see a pi here, right? This is yellow in color, so you have to press shift first and press this button. Calculator know that you want to key in this pi. Then press equal, change to decimal. Okay, you see your calculator will just give you until here, but it's actually go infinitely, no stop, no ending. Okay, this is the value of pi. So same thing, order number, you see an E here, red color. If you want to know its value, just press alpha first to let your calculator know that you want this red color one. So press this, the calculator will give you order number, press equal. So the same thing is actually go infinitely, no end point. You don't see any repeating part, right? So order number is not a recurring decimal. Pi is not a recurring decimal. So pi and other number, they are not rational number. We are not able to write them in a fraction form.